is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's home. Boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Welcome everybody. Welcome to SkyTour Livestream. It is me, Mark D'Antonio, here, of course, with everybody's favorite astronomer, Daryl. Hi Daryl, how you doing?
Hello, Mark. I'm good. You? Hello, everybody.
Just fine, thanks. We have the pleasure, as you'll see here in just a sec, we got a comet in the sky tonight, and we're checking it out. As you can see, I've already been taking some photos of it. I just wanted to make sure we got it. Tonight's stream isn't going to be terribly long, but it was to show you the comet and talk about comets and where they come from. And first of all, let's go see where it is, first of all. So if we back out of here, we see our beautiful sky globe here. This, if we bring up the constellations, this, you see here's Leo the Lion, and right next to it is Virgo. And dead center in the constellation of Virgo, by this drawing I should say, is a comet. Now Spica, the brightest star in Virgo is right here, and then the comet is up here, kind of in the middle. All right. And as we zoom in, all right, let me just turn those off. As we zoom in, you can see that we are in a very interesting neighborhood because we've got galaxies all around us. All right, and that's kind of where we are. I'm going to show you something from. I'll show you this comet now, and if you look at this over here on the left side of this over here, you see that star right there? I took a picture of the comet yesterday, and it was just above this star. And today it's over here. And when I first started taking pictures last night, I was just doing it myself. It was here, and then the comet was here. So it literally moved across the top of that star, and now it's all the way here after just one day. So pretty cool, huh? So I want to just say hello to everybody who's here. I want to say hi to, let's see, I think we had someone who's very proud of the fact that they were here first. No, it was, I was going to say it was you, JSCO, but I know it wasn't now. Stan, Two Rivers Observatory. Nice to see you, man. Andy Lino's with us. Good to see you again, Andy. And, of course, Sam S. is with us. Genghis is with us. Nice to see you. This darn Daryl guy keeps showing up. Laura Newbert. Hi, how are you, Laura? Just so good to see you. I'm glad that you came out to hang with us. I'm just going to color correct here. There we go. And Daisy and Zoe Amethyst are with us tonight. Tim F is with us. The Desert Dwellers hanging out there in the background. And Michael Hedrick. This is Comet. Yes, this is Comet 2023. Tsingshan. Susingshan. Atlas. And this is the comet that you, I believe, had asked about the other night, Michael. And we're putting this up just for you, because you had asked. We don't forget. So it's nice to see you. Trisha Ferrara is with us. And we have Michael's Asylum. Nice to see you. Yeah, it's a fast-moving comet, as you just said. Yeah, it was above this star yesterday, and now it's here. Yep. And let's see. Let's see. Fantasy's with us, too. Nice to see you. Now, we have a question already from JSCO. JSCO says, what concerns are there about this weekend's forecast solar storm that you're aware of? Usually we're concerned when we have a very high level X-class flare. I don't know what the flare level is. Daryl, do you know what the flare level is? That's
Oh, yes, I do. Well, I forget the sunspot's number. It's the main one going right now. It had 4 X-class flares in one day.
Nice.
A day or two ago. And they're saying like 3 or 4 CMEs are supposed to arrive here pretty much simultaneously this weekend.
Oh, cool.
And if you want to get excited about something, they had a graphic up over at spaceweather.com with this sunspot group. It ends with the number 4, if I remember correctly, compared to the Carrington event sunspot from 1859. And they're like the same size. So it's real big, and it's been spouting like crazy. And the big sunspot before this one, which just went over the far edge of the right-hand edge of the sun, it was flaring like crazy too. So things are getting interesting this weekend. We're probably not going to see a Carrington event, but there is a fair chance of some upset this weekend, which would probably mean auroras visible farther south than usual.
Looking forward to that.
Yeah, stay tuned for more information.
Of course, I've got to say, it was a few years ago when this very telescope here got hit by a magnetic storm, and it threw our circuitry off, and our telescope started doing wild gyrations. We had to get it repaired. So we've since grounded everything properly, so the building is now properly grounded in case of such an event. But we don't have anything to worry about with this object right here. This is, ta-da, Comet C 2023 A3 Suchin San Atlas. And this is a comet. Right now, it's 1.77 astronomical units away from us. For a little bit of scale, that's just a little bit. It's about Mars from us. So it's actually about that far out. Now it went from here to here in one day, right? And so that's pretty interesting how that happened. Okay, let me. I see what I did. I had my threshold set too low. I was over ambitious. So now we'll start getting it in there. Okay. So we're gonna take a bunch of these frames and we're gonna just let them accumulate just a little bit. You can see right now we're getting dust illuminated by the comets is outgassing dust, and the dust is being illuminated by sunlight. So the cometary dust has the color of sunlight. We don't see an ion tail at this point. It's possibly a little too far away to see an ion tail, but it would be a tail that isn't necessarily in the same direction as this tail. In fact, they usually aren't. The ion tail points directly away from the sun, and the dust tail kind of follows the path the comet's taking around the sun, and it's just like shedding all this material. Every time it goes around the sun, the comet loses a huge chunk of its mass. Any comet does. And eventually, the comets that we know and love, like Halley's Comet, will be no more, because they will no longer be of any size that matters. Many comets, over time, most comets, all comets, will eventually outgas out everything. And all that's left is whatever rocky core might be left inside, and thus they become a small piece of rock. And in the larger comet's case, an asteroid, which is buried inside. It's like when you used to get soap, and inside there used to be like a little tiny creature, a little prize inside soap. Convince kids to scrub a lot. It worked for me. And when I got this stupid little plastic bear, I said, man, that was a waste of scrubbing. But in the core of a comet, you have a rocky core in all likelihood, and so.
You're not thinking of Cracker Jacks, are you?
No. I'm thinking about bars of soap that had these little animals inside of it. But you scrub, and finally you see this creature starting to come out of the soap. And it turned out a little plastic teddy bear that I got. And it's like, oh man, what a waste of showers, as a kid.
I don't think I ever saw that soap.
Oh yeah, I got it. I almost can remember the name actually. Anyway. All right, so we're gonna save this guy just like we see it, and it'll be up on the server. Now, what we're gonna do is we're gonna clear this and start again. And why in the world am I doing that? Well, because I want to show you the movement, because you can see movement between shots. So there'll be a slight difference. Now we might have to animate it to show you. But when we animate it, you'll see that it is actually moving. Very cool. We endeavor to show you everything that's going on out there in the night sky. I will be at Contact in the Desert May 30th through June 3rd. And I'm doing 4 lectures. Actually, 3. I'm doing 1 lecture myself. The second lecture is going to be one of these, a SkyTour live stream for everybody. We're going to stream it from there and have a studio audience. Zoom! Thank you, Starlink. And the third lecture is going to be a lecture on, how the universe works and how UFOs can make their way here, in my view. And the fourth one's actually going to be a dual thing where I'm going to be helping Ben Hansen on his Skywatch. Whenever Ben and I are at conferences together, we'll usually do a Skywatch, and he does a Skywatch normally, and he'll ask me to be his astronomer for the night, which is kind of fun. It's really nice. It's always a busy time at Contact in the Desert. That's in Indian Wells, California, May 30th to June 3rd. And I'll be doing my SkyTour live stream on Sunday night. That Sunday night, which I think is June 2nd. Or yeah. The third is third's Monday, and I'm doing a lecture on that Monday afterwards. So that's cool. We will have a table. We will be selling T-shirts and everything that we have for SkyTour livestream. We have a limited number. They have a nice, cool logo on them, and on the back it says "The Universe Live in Real Time" with a telescope. Now, in each of my lectures that I do out there, we're giving away astronomical equipment. We're going to give away at least one telescope and at least one pair of binoculars, and maybe more than that. We'll have to see. All right, so we've got lots going on, and we'll say hi to Louis Ta, and we'll say hi to Izabela, and Cosmic Ray is with us, and Soapy Smith.
I don't think Isabella's here yet.
Somebody wrote, "Ed Izabela, are you awake?" Okay, maybe not. That's okay. I'm on record as welcoming her before she gets here. Okay, Rascally Rabbit's with us. Michael Galea, how you doing, man? Good to see you as well. And thank you for talking about the Carrington event, by the way, for that question. Ricky Ricardo's with us. Lucy. Ricky, hello. Nice to see you all. So here's the comet. There's a satellite that came through, and I'm going to save this again, even though it's a short period of time. But we want to get the motion and the movement. Now, this is the star I was talking about before, and when we look, if we compare it to last night, it started right about here, and tonight it's gone all the way to here. So this is the line of travel that this comet's taken.
We might watch the star just ahead of the head of the comet right now to the right.
Okay.
We'll probably see that gap close up over the evening.
That's right. Yeah, we will.
Did you know Lucille Ball supposedly got radio transmissions through her teeth?
I've heard that before. Back when fillings were silver fillings,
Yeah.
People could actually end up with a resonant frequency, and they could actually have radios playing in their mouths. It was very crude, but it could happen. It was just a weird resonance that was set up because of the proximity of the fillings to each other. It acted like a crude tuner. You know, if they close their mouth a little, they get a better station. I hope she didn't have to run around like this, you know. Listen to this song. Have to like hold her mouth open at a really odd angle. Yeah. Okay, let's see.
Remember, I saw her on, I think it was Tonight Show one night. She was talking about that.
Mm-hmm. Here's our
Marianne is here.
Hey, Marianne. Marianne was just out at the telescope today. And here's the constellations for tonight. Okay, that we see. This is the all sky. You'll be able to do this when we get this up on the web side. Okay, so we'll be able to do that with you. So right now you can see Leo here. There's the backwards question mark. Okay, and the tail of Leo, the line here. Then Ebola. And so Leo has tons of incredible galaxies in it. And if you hover over these with your mouse, you can actually click on them and end up going to a site that'll show you everything, show you all the details of it. All right, so back to our comet. All right. So I'm going to now.
Izabela is here now. Hello, Izabela.
Hi, Izabela. We are looking for you. All right, we're going to save this again. Save it exactly as seen. And if you're wondering what we're looking at this comet. 2023 A3 Suchin-san Atlas.
Night, Marianne.
Yeah, she was actually very tired from everything she's done today. She went all the way to the observatory with Terra Diulis. Did some tests, fixed the circuit out there with Terra that we had, our Arduino circuit that runs the observatory. It was intermittently failing, and so we fixed it. She fixed it with Terra. And then she drove it up into Wickenburg to a friend of ours who fixed or replaced the power supply. I felt that the freezing of the comet. I felt the freezing of the system on occasion was due to the power supply, and so it could also be due to the graphic card thermally shutting down. So he cleaned the graphics card out, and it had a lot of junk inside, and he cleaned it out. And a little bit of heat can go a long way on those things. So,
Izabela, the red star over on the lower left is where you saw the comet in the image last night. It's moved that far in one night.
yeah.
Izabela actually identified that star last night.
Oh yeah, I think let's try this. Let's do an annotation and do a whole sky annotation. So let's see if it finds that star for us.
If I remember correctly, it's a double star too.
It is.
Looks like one, though that may not be the binary.
No, it actually is.
Is it?
Yep. Okay, so this star must be, that's highlighted, is just out of the view. So I gotta zoom out to see it probably. There it is. And this is moving now to a close approach to this galaxy, at least from here. Because the other galaxy we're looking at was down here somewhere.
Yeah.
All right. You'll notice our satellite trail is fading. That's because the telescope is laying images on top of each other, and this was just in one frame. So little by little, the black of space is going to drown that out over time.
Izabela, some comets are fast, some are slow.
Depends on the orbit.
Yeah, and I'm frankly surprised it's moving this fast, as far away as it is.
It's about as far as Mars.
To see, I bet it's farther than Mars.
1.77 astronomical units from Earth. So
Yeah.
it could be a little further than Mars from our perspective, depending on where we are relative to Mars. No, Ray, there was no STLS last night. I just opened up to check out this comet and did some private photos. I wanted to have some data for doing what we're doing tonight. Okay, so we're going to clear this and start again. This time, instead of 10-second photos, we're going to do 20-second photos. Yeah, so we'll clear it. Do 20-second photos. Whoops. It would help if I got that right. Here we go. Okay. So comets are interesting creatures. They are actually the oldest things in the solar system, primarily because they existed probably before the actual solar system was made. They have remained unchanged since the solar system was formed. And so they have been stuck in a deep freeze for billions of years, 4.5 billion years. So when we see comets, we see them as they were exactly when they were formed years and years ago. And so they're made of various ices, ammonia ices, carbon monoxide, carbon dioxide, has methanol, water ice, and it's got compounds that are hydrocarbon compounds. Sometimes they have a lot of compounds that are dangerous to us. Many times when we look at comets, they're going to have a greenish tint. That greenish tint is due to two things. Number one, it's due to carbon molecules. Second, it's due to carbon mixed with a single nitrogen atom, and that is what we call cyanogen, cyanide by another name. So it was Flammarion that got himself in some hot water when he famously said back in the previous centuries that if a comet comes too close to the Earth, we could conceivably die because of the cyanide that's in its atmosphere, and thus was the birth of the comet pills to save your life from comets. Yes, never doubt that humans can come up with some stupid ass thing, and that's what he did. That wasn't Flammarion.
Huh?
It wasn't Flammarion that came up with the comet pills.
No, that was every crackpot
right.
snake oil salesman. Flammarion, don't sell him short. He was like the Carl Sagan of his day.
Yeah, he was.
Late 1800s, early 1900s.
Yeah, he lived to rue the day when he made that statement about the cyanogen.
Yeah.
So
I mentioned before Arthur Conan Doyle, the guy who wrote the Sherlock Holmes stories.
Mm-hmm.
He wrote a story about that, about the comet being poisoned, supposedly. Comet.
That's right. You
that flew by the Earth, and it looked like it killed everybody, and then everybody woke up again a day or two later.
Yep. Yeah, this comet is 1.7725 astronomical units from us right now. That means that the light we're seeing from it right now took 14 minutes, almost 15 minutes to get here. 14 minutes, 44 seconds to get here from that comet. That's how far out it is. Keep in mind that that's at a point in its orbit where it travel time to Mars, depending if we're on the same side of the orbit as Mars, is anywhere from 4 minutes to 22 minutes if we're on the other side, farther and closer. So at 14 minutes and change, this comet is actually probably, I'm going to guess it's on approach to the sun, and I think maybe as the months wear on, we'll see it better as the fall approaches and so forth.
Yeah. I mentioned that the other night. I looked up, and I think they said it's supposed to be at its best late summer, early fall.
Yeah. And at the speed it's moving, where will it be, I wonder?
I don't know that yet.
And of course, this is one of many comets, as actually Cosmic Ray just pointed out. But it's one that was within our reach. It's one that Michael Hedrick asked to see the other night, and he is a loyal follower and viewer of everything we do. So we figured that, hey, why not? We'll do it for you. Actually, sorry, Michael, we can do this for anybody, but I just wanted to make you feel special for a minute.
There's actually another comet out there right now that's brighter than this one is. It's called Comet Olbers.
Where is it?
It's in the constellation Auriga. It's probably set already.
Yeah, that's
It's up near where the Horns of Taurus intersect Auriga.
yeah.
Beta Tauri, if I remember correctly.
Mm-hmm.
Yeah, it's probably getting pretty darn low after sunset.
Yeah.
But it's like magnitude 8 something.
Mm-hmm.
This is magnitude 10.1. Are you there?
Yeah. No, I'm here.
Oh.
Sorry, I was writing something to Izabela. Okay, let's There we go. Yeah, so a 20-second shot shows the extent of the tail pretty much here. Let's see if there's anything else in here. Let's pump this up and see. It's hard to tell. It looked like it might have a little bit of a fan process going on here, but maybe not. Hard to tell.
Genghis, it's surely happened over the course of time since the beginning of the solar system. Some people think having a brain lock, the famous Russian impact.
Yeah, you're talking about the Siberian impact there, yeah.
There is some discussion whether that might have been a comet. I've talked in the past about a place over in the Middle East called Abu Huraira that they think a comet may have come in over
Jordan now.
Eastern. I'm sorry.
Isn't that Jordan now?
Syria, I believe.
Syria, okay.
It's up close to where Syria and Turkey come together now. A place called Abu Huraira. Back, I forget when, it was over like 12 or 13,000 years ago. Evidence that something very bright and very hot happened in the sky over Abu Huraira.
Yeah.
And it basically incinerated the place.
Yeah.
Temperatures got to thousands of degrees almost instantly, and basically burned everybody and everything to vapor. And they were thinking that might have been a cometary impact.
I think it actually it fused some of the ground to glass.
Yes.
Yeah,
yes,
and there was fragments of that in the walls of some of the structures.
Uh-huh.
Yeah. Fantasy. Yes, I got your message. I haven't acted on it yet. I'm sorry. I will look at that image again, and happy to do that. Yeah, the Tunguska impact was actually quite interesting. I mean, it literally burned the shirt off of farmers' backs 40 miles from the impact. You know, that's pretty huge. You know?
Michael, I do not know the answer to that question.
Well, read his question.
Ray spoke of Comet Shoemaker Levy 9, but has there ever been a double comet as it arrived in our view? I can't answer that question. I wouldn't be surprised if it had been at some time.
In our early history, that's possible.
Yeah.
Because there was a lot going on. In fact, quite a large number of comets have struck the Earth because a lot of the water we have came from comets. That's in part, you know, I can't say a lot, I mean a certain percentage. So.
And as Ray said, if Hale-Bopp broke apart, well, uh, probably big comets, broke up in the past and became a bunch of smaller comets.
Yeah.
It happens. That's often the way these things work.
Yep. And take a look at this, Daryl. Here is that comet with the star that you were talking about. It's now closer.
Mm-hmm.
As we're watching, guys, the comet is moving closer to the star. Before we're done, it'll probably be under this star. And knowing Izabela, she's going to take this and produce a little movie, because I've been saving these, Izabela, so they'll be up on the server for you. So that's cool.
And here's where they're landing.
Oh, thank you for putting up the link.
Oh.
Okay, I started it over because we want to get a fresh look. See how close it is to that star right there? Let's zoom in a little. You can see some differentiation in the tail a little bit. As far as the speed of the comet, well, that's a good question. I would have to say that, let me look up and see if any speed's been calculated. We'd have to calculate it. It's gonna change. It's in an elliptical orbit. If it's in an elliptical orbit, that's gonna change. So we'll find out. Let's see.
I'm looking.
It's going a fraction of a degree per day, and that's only going to give you a 2D projection on the sky of where it's moving, not a full 3D value of its actual speed.
Comet will be closest to Earth on Sunday, October 13th, 2024.
Yeah.
And it'll be 0.47 AU away at that time. I'm looking for the speed. I haven't seen it yet.
Yeah. I couldn't find this speed directly. I find all kinds of other data, but
Right.
it's possible the speed has yet to actually be calculated. They have the orbital elements, and that's all that matters. We know how to predict its future positions. Okay, we're going to save this shot now. Save exactly as seen. Now we'll clear it, and let's see how this looks the next time it comes in. It's probably going to look about the same. We need to give it like 10-15 minutes in between each shot to really be fair. But I'm doing 10 photos or so at once, or at a time, as a stack, and then clearing it out. So it's fun, huh? Seeing a nice comet. It's the first one of the season for us. Oh. Spider coming down in front of me here from the ceiling. I know you. Come on. kill spiders. They help out. They're good.
I agree.
All right. Hey, C&D boy, how you doing? Okay.
Whoops. Margaret, excuse me a moment, please.
Sure.
Right back.
Sure. So, well, Marianne and Tara were out at the observatory a good part of the day, so I was going and talking to them through that fix of the circuit out there, and then they took the computer to have the power supply changed, and they reinstalled it today. So she's very busy, so she's probably sleeping out there. And then I had a show from 8 to 10 to do, UAP Crossfire, and then I got out of UAP Crossfire and literally set up the stream and started streaming. So I've been kind of busy today, just doing all this stuff. Okay. AI and Messenger, 35,000 miles per hour. Okay. As a speed, possibly. James Hyatt, what's happening, man? Oh, Genghis says that was a good show you did, Mark. Crossfire and Jellyfish Talk. Oh, yeah. The Jellyfish UFO. Yeah, I thank you very much. I just give my opinion, you know, and it's not like just plain old guesswork. You know, it comes from doing analysis. And if I'm wrong, that's okay. I don't mind being wrong. I don't have an ego. You know? Hello, Andrew Tedeschi. How are you? Reviewing the Comet 2023 A3 Tsuchinsan Atlas, which is right here. It's about 1.77 astronomical units away from us. And if Michael Hedrick's right, it's moving about 35,000 miles per hour. Laura Newbert says, were your talks at Contact Nadeza be recorded? Last time they weren't, and I don't know. It's the biggest conference, I think, in the world on UFOs right now. And so I don't know. I'm doing 4. I'm doing one lecture when I first arrive, and that one's going to be on the. It's going to be about the universe. The next one is going to be a SkyTour live stream with a studio audience. I'm going to have an audience, indoor audience full of people, and you guys will all be joining us, hopefully. And then I'm doing another talk, which is going to be the one where I talk about the state of the scale of the universe a little bit, and then I'm going to show the scale of life on Earth by doing my. It's become famous. I hate to say it that way, but it's in demand. They want me to bring my toilet paper history of the Earth, so I have the history of the Earth written on a roll of toilet paper, and I go out into the audience and I unroll it, and they hold up all the important times, and we talk about when dinosaurs died. The thing about it's 117 feet long, this roll, so when it's fully unrolled, what's interesting is that you see that out of 117 feet from the time the Earth formed to today in that room, dinosaurs died 18 inches ago. And in other words, they're recent history, not ancient history. That's one of the revelations that you come up with. Okay, we're going to save this here and do another one. Save exactly as seen. And we'll clear and start again. We're just tracking movement, so we're going to see this move. So that's pretty cool. Yeah.
I have a question.
Yeah.
Are you still on the same roll of toilet paper?
No. Yeah. I have a little joke. I say to people before I pull it out of my bag. I say, now we're gonna bring out a very fancy piece of scientific equipment. It's something I've used a lot before. And I pull out a roll of toilet paper, and of course people say, "I've used that a lot before." Yeah. And I go, "Well, not in that way." And then I proceed to do the scale of the Earth on it. And people seem to like it, you know. It's the thing they end up taking pictures of, that's for sure. A lot of fun. Look at that star, Daryl. You were right. See? It's even closer now.
Uh-huh.
Yep. There's the comet. 2023 A3 Tsuchinsan Atlas. Yeah, during the COVID lockdown, I couldn't go out with that toilet paper. That'd be stolen. Toilet paper. I haven't been able to see that in months.
I still have the most third world excuse for a roll of toilet paper from the beginning of the pandemic in 2020.
Oh, yeah?
I mean, it was, there wasn't any toilet paper to be found anywhere at the time. And I found a package of this really dismal third world toilet paper. It was all that Walmart had for sale. And I still have it. I've never opened it.
Sandpaper?
I never will.
Sandpaper?
Well, it's brown. I'll give you that.
Okay, it's like the non-absorbent absorbent paper towel.
Yeah.
Yeah.
I'll probably pass that down to my nieces and nephews,
Yeah.
since I don't have any kids.
But you sure do have toilet paper.
So, have you reframed the image, or are you zoomed in a little bit? Because I don't see that star on the left anymore.
Correct. I've just zoomed in a little bit. It's actually over here if we move over.
Okay. All right.
Yeah. So I could leave it there, but I was just kind of recentering just enough.
Sure.
Yeah. And then down here is the other galaxy that we're passing slowly.
Mm-hmm.
Yeah. And when we annotated, it didn't even know what that was. I'm going to hit a whole sky and do that. We have to re-solve. Let's see if it knows that galaxy. It knew the star, but it didn't know the galaxy. Yeah, see, it knows the star, Hipparchus. It's a Hipparchus catalog, 63093. But this galaxy is unknown to this. But it doesn't mean it's not known. It doesn't mean we've discovered a galaxy. It's certainly well known. We just haven't figured out which one it is yet. Okay, we're going to save this one with 11 frames. And save exactly as seen. And clear again. You say, why are you doing that? Well, because the comet's moving so fast that if we take more than 10 to 12 frames, okay, it's going to get blurred. Oh, look at that. We have a little blinker over here. Know what that is? It's a rapidly spinning satellite that spins, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, like 10 times in 20 seconds. So, how about that? So, that's kind of cool. Once every 2 seconds, it's rotating and catching the light, and that's why it looks the way it does. We call these tumblers. It could be a rocket body that was used to send something to geosynchronous orbit, 22,000 miles out. But that's what we see. That's the tumbler. And it is going this way toward the east as expected. And this next fourth exposure, you'll see the next line of them here. There they are. That's cool. This is going to be below that star in no time.
Yeah.
Let's see what else we might want to check out while we're here, just to take a break from this if we want to. Oh, the Dust Devil Galaxy. NGC 4753. Do you know why it's called the Dust Devil?
Not offhand.
Okay, neither do I.
I could kind of imagine.
Yeah, let me guess. It looks like a tornado, right? Okay. All right. So here's what we'll do. We're gonna save this. We're gonna save exactly as seen. Now we'll come back. And first things first, we're gonna go back to our night vision enhanced mode here. Okay. And you see the comet in our advanced mode here. We'll shut this off because we know what it is. And now we're gonna go to the Dust Devil. I was looking to see if I could see it blinking, obviously, here, and I cannot. It's very dim. It's probably fading out, actually. Okay. And so, what I'll do now is two things. I'm going to move this over a little bit. Okay. And I'm going to come back here to our planetarium program. And let's go check out the Dust Devil Galaxy. I don't know what that was. What is it? Oh, 4636. Interesting. It's a galaxy that doesn't have a marker on it. Okay. Alright. This might be small, but let's go check it out. So we're going to go a little bit to the west and to the south. So the telescope will move a little bit. Ooh, there we go. And oh, that must be the Dust Devil Galaxy right there. Okay, let's center that up. Boop, boop. Here we go. All right. Center that up. Get it in the inner ring. Alright. And once we're close, that's good. That should be close enough. Let's try now a 25 second shot. Okay, and off it goes. And we'll call this the... I'm going to copy that because we're going to come back to that. And this is going to be the Dust Devil Galaxy. Okay. Alright, let's go into our live stack and clear the last image. Get rid of this. And there it is, the Dust Devil. It must have a pretty pronounced spiral structure. That's my guess.
Looks kind of dusty at any rate.
Yeah.
So can you find the comet again when you're done here?
Of course. Already have the coordinates filled in right there.
Okay.
You just have to say go to. Okay, this one is... Oh, here's the Lost Galaxy of Copeland. Remember that?
Vaguely, yes.
A, B. This is measure 49. It's an elliptical. We make our way up into the Virgo cluster. Plenty to see up here, boy. Let's see what this looks like. Let's see if we can enhance. Okay, little enhancement. We'd probably have to let that go for a while, huh? Just to be able to catch that. Okay. We've done 5. I'll save it. Any particular galaxy you'd like to see in the Virgo cluster before we head back to the Comet?
I'm good.
Okay.
Knock yourself out.
We did Markarian's chain. M60, that's an E2. That's an elliptical galaxy. That's what the E stands for. Alright, so let's come up here. The blow dryer galaxy, remember that one? You can check that one out.
Uh-huh.
And this guy, the Kick the Can cluster. Well, let me check it out, being that it's just a cluster and it's not anything crazy. Let's we'll save this one more time because it's starting to show some detail in it. Okay. And now we'll come back here and get ready to go to the next item. Okay. Alright, and now we go to Kick the Can. Here we go. Telescope is moving, as you can see up there. And it's going to be almost directly overhead. There it is. Look at all that detail. Alright, let's get it down here into the center of the frame a little more. Alright. Alright. Now we're searching for a guide star. By the way, the Benson telescope is going to use an off-axis guider with a guiding camera. And the reason we're doing that is because we're going to be doing narrowband imaging. And I don't want the camera at the back end behind the filter wheel, because when we start doing H-alpha filters and O3, there might not be a star that the guider can pick up. So we have to do off-axis guider. So that's what we're going to do. Alright, this will be 20 seconds. We've looked at the Kick the Can cluster before, haven't we?
I don't recall.
Yes,
I remember the blow dryer.
Yeah.
That was a mystery object, I think, in 100.
Oh, I see this, remember? Little tiny cluster. Really pretty.
It is a globular.
Yeah. Let's check that out. Alright, kick the can cluster. Globular star cluster, magnitude 10.74. Distance, where are we? It's... Wow. 61,978 light years?
Oh, I believe it.
So that's on the other side of the galaxy, effectively. That's pretty cool. Let's just, let's add a little contrast here. Yeah, it's quite a distant galaxy. I'm sorry, distant cluster. Nice. Hey DK, what's going on? Yeah, I'm not gonna kick the can either. Izabela, I really want to have a word with the people that make up these names. Maybe it's called kick the can because it's a distant cluster and you kick the can down the street to get it farther away from you, so maybe that's why. I don't know. I don't know. Ah. We're only going to go a few on this, so we're going to go back to the Comet, and you'll see that it's moved quite a distance from where it was. Because we're going to go here next. Okay, so we'll save this. Do exactly as seen. Okay, and it will clear it. Go back to 1 second. That was a cool cluster. Nice to see. Now let's go see a galaxy that would rather fight than switch. Kind of appropriate. Twinkle, twinkle, little star. Alright, a little north now. There you are. There's my black eye galaxy star. That's not a star. You can actually see the black eye in here. You can see that. Really interesting confluence of dark dust in the core of this galaxy. Okay. 25 seconds. That's better. Our yellow box over there is our progress bar. So let's come in here. You'll see the cluster. Alright. And we'll clear that. Because the Black Eye Galaxy is now our target. Hubble took a beautiful image of this. Hey, Blues. Yeah, I know. He says, this song's making me sleepy. I know, I should have known better to get a lullaby. OG Skywatch, what's up? How are you? Cosmic Joe, what's happening, man? Yeah, we've had some experiences ourselves, man. We're in the right place. I'm the MUFON's chief photo and video analyst, so I can help you with any physical evidence you have. Paul Martin's with us, asking what camera are we using. I got the camera. We're hyperstarred. We're the only hyperstarred mead on the planet, actually. No other mead has been hyperstarred like ours. And the camera we're using is tuned to give us the right arc seconds per pixel on this. That's the ZWO 183 MC Pro. I'm in the process of determining the right camera for the proper arc seconds per pixel distribution on the new telescope for site number 2 here. Look at that beautiful galaxy. Laura, thank you for coming. So nice to see you here, Laura. Hope to talk to you soon. Okay. I'm going to move this over a little bit. And then go here just to give us some more contrast. We must have had some failing frames. Yeah, we have. Okay. All right. Now our frames will probably work. Yeah. Oh, gee, if you find a meteor and it lands on your property, then it's yours, yes. If it's not, pick it up and throw it onto your property and say, ooh, look what I found. All right. Okay, we've got 4 exposures. This is our full width half maximum filter showing us the greens are the frames that are kept, the reds are the ones that are rejected. This basically is a measure of the roundness of the star and how sharp the star is image-wise. And if it's going to be very sharp, then this number is going to be low. If it's going to be moderate, then it'll be about here. If it's much higher than this, we don't keep the images because the stars are too bloated. But these are pretty good. The more stack we have, the less noise, like this modeling you see here, that we'll have. It's pretty cool. So for instance, we want to get rid of some of the noise, then this filter here, the bilateral filter, can be used, but we want to get rid of color noise, so we do this. You see how the color, the other spurious color goes away. Let's zoom in here. I think we're starting to get some good detail in this now. That's pretty good, huh?
I'd rather fight than switch.
Yeah, that's what I said when we went to it. You may not have heard me.
Oh, I say that every time I see this galaxy.
I know. My parents, that was their brand. They always used.
Terrigen, if I remember correctly.
You are correct. And it was like, gross. Paul Martin asks, I'm right in thinking you're using APT for plate solving? You're running a mini PC at the mount? Actually, we have a tower at the mount, actually, but we are converting it to a mini PC. I've got one right behind me. I've got one sitting on my desk here. All of our remote observatories are going to be run by mini PCs, yes. And we're using the Camrui AMD Ryzen 5, and it's been very reliable. That's actually the tower. We're going to be making the mini PC that as well. And we're not using APT for plate solving, actually. We're using SharpCap for plate solving. We only use APT basically just to move the telescope in the right ascension and declination. SharpCap is actually doing the bulk of the stacking, dynamic stacking, camera operations. And then to move the telescope, we can either use APT, but we don't. We're using a Stellarium hooked up to the telescope. On the new systems, we're going to be using Green Swamp Server GSS on both systems. This is SkyTour Sonoran you're looking at right here. SkyTour Benson is going to have Green Swamp systems on it as well, Green Swamp Server on it as well. And we're changing this fork mount on this telescope to a Skywatcher EQ6 R Pro. And we're going to put the new Celestron 11 that's going out in Benson on a same Skywatcher mount. So in both of those observatories, the telescopes will be run with the same server, and will make it easier to run both at the same time, because our goal is to have several screens you're going to be able to look at. You're going to see this screen where you'll see the hyperstarred version, okay, here of this, and then you'll have another one which is a much more close-up view of it being done at the same time. This telescope has a 1.5 by 1 degree field right now, and that's because we changed the camera. It used to be 2 degrees by 1.5 degrees, so it was 4 full moons across and 3 full moons tall. Now it's only 3 full moons across and 2 full moons tall. Yeah, we're cranking them in now. Look at that. I wore my glasses for a while today on the UAP Crossfire. All right. Okay. Hey, Corin Lewis, how you doing? And thanks for offering that. He says, Green Swamp Server is a good software. I use it on my Star Watcher Adventurer GTI mount. Yep. The problem is this is an LX600 telescope, and it has the Starlock guider. It's beautiful. It works great. However, unfortunately, the telescope is no longer able to get parts. So if something goes seriously wrong with it, we are out of luck. So the idea is we're going to take it off the forks and use the very, very good optical tube and put that on the new mount. And we should be good at that point. It'll still be a hyperstar system. And because it's going to be hyperstar, what that means is it's a Schmidt-Cassegrain telescope, so the light goes down the bottom of the tube, hits the mirror, goes up to a secondary mirror, and then comes down through a hole in the mirror and out the end. That's typically how these work. What we've done is our light goes down the tube, hits the main mirror, comes up, and instead of hitting a secondary mirror, it goes into a lens, which takes it to the camera directly. So that speeds up our telescope by 25 times and makes it go from like a I thought it was an f8, Daryl, to f1.8. So it actually speeds it up quite a lot. I noticed that it's time to focus too. We're going to save this. Save exactly a scene. All right. Okay, the Black Eye Galaxy is a really cool galaxy. It's a strange shape because of the interactions it's had in the past. Its distance is it's 24 million light years away. So that's pretty cool, but that means that with the light you're seeing from it left 24 million years ago. Think what the state of the Earth was 24 million years ago. The light you're seeing right this instant left at that point to come here from this place. Isn't that crazy? Okay, we just saved that. So let's go back here. And we'll just do that. And we'll zoom back out. Okay. And now what we're going to do is just go to these coordinates, because these were the previous coordinates for the comet. And you'll see where that actually takes us. There's the comet right there. All right, so we're going to move over. And as promised, that comet is now just past the star that it was to the left of. And now we're just going to swing over a little bit more here. Go to the left. There's the comet right there. All right, Corin, have fun at work, huh? Okay. All right, we are guiding down. So let's go here and come back to a 20-second. Shot. I write 20,000 because it's 1,000 milliseconds per second. Okay, Paul Martin says, another question. Your scopes are remote. How do you manage to do lights and darks for pre-processing and sharp cap? I actually do flat frames from here, and the dark frames I do when I go out there, and I create a whole set of dark frames that I end up using. And I can pick and choose which dark frame I'm going to use, and it works very well. So we're using flat frames right now, and we're using darks right now. All right, and so that's actually working out okay. Let's just go here and capture this image. There we go. See all that noise? That noise is gonna go away. I'm just gonna pull this out, and some of it will go away. There's the star Daryl was talking about. And the comet was here just a few minutes ago. And now it's here. Woo Riders says, how many UFOs have you spotted in what shape? In the satellite, in the view, we haven't seen any UFOs. However, in our all-sky camera, which is this guy, okay, with parameters, and we can do constellations and so forth, we have seen very strange things in here, which I cannot explain. Look, there's a satellite going right there. You see that little faint line? That's a satellite. Interesting. The summer Milky Way comes up around 1 in the morning their time, and by 3:30 it's right about here. And so if we actually do stay up late one night, we'll catch the early summer Milky Way. I can be convinced to show some of the footage. I think that we caught the Chinese Shenzhou rocket re-entering the Earth's atmosphere. I'm pretty convinced that's what it was. But then we had a circular anomaly which went in a complete circle way up high in the sky and with only one small light. That's very strange. You're welcome, Corin Lewis. Yeah, you can send it to me as MUFON's chief photo and video analyst. I'm happy to look at it. You can find us here at SkyTourLive.org, and our email is up there. Plus, you can send it in a comment, say you want to talk to me, and I'll get it, because I'm one of 3 people that get the email on our nonprofit site. So that's okay if you want to send it there. But contact me there and we'll start a dialogue, and I'll check out that photo. Hey, somebody out there has the real thing. Without doubt. Alright, let's save this guy with 9. Oh, I did Black Eye Galaxy. Wrong one. Okay, I'm going to change the name. See if it remembers. It does, okay. Yes, change the name. I will say save. Okay. Good. So what's actually saved up there on our server is this file right here. And you're free to download that, check it out, explore it. You know, zoom in, check out stuff. I can see we got to focus. Why don't we do that? Daryl, you turned into a pumpkin over there?
Not yet.
Okay.
Getting there.
I'm going to take us back and do a little focus arrangement first. Okay.
Excuse me.
Okay, I think I went too far on that. I didn't, but I'll... Now, this is the kind of blues I like to play on my guitar right here. Just lay back and just riff along with it, play along with it, take the lead. That's a lot of fun. All right. Oh, wow. All right, so what we're doing is we're sampling the stars. You can see the square boxes. And we're building a curve over here. This curve is going to be a parabola. At the bottom of that curve is going to be the lowest spot. That lowest spot will correspond to the place where the stars are the smallest when you focus them. And it's taking the samples and averaging amongst all these samples. So for each sample it is. So it's taking, like, right now it's 37 stars, 41 stars. It's going to make, 41 samples and see how they compare to the previous 39 or whatever. And the smallest circle wins, basically. And you can see the curve going down here, and then it'll start going up when it's going to reach the other side, when it reaches the bottom of the curve. And the diameter will increase when it starts to go out of focus again. And we can already see that this is probably where the line's going to go, right about here. And when it goes there, we can just click on best focus. If we let it go through, it'll automatically refocus at the end of the run. Sometimes it will be fooled and doesn't find the center. So we'll do it a second time if we have to. It's not a big deal.
Oh, that one looks a little lumpy.
Yeah. It's trying to find it right now. If it can't do it. So we'll have to just redo it. So let's see. Let's reset. And I'm going to go in here. All right. Let's redo it. We can't have lumpy focus now.
Woo Riders has a question. How far can you view into space? And have you ever discovered something new? And then Andrew Tedeschi has a question of you in particular.
Okay. So go ahead. You going to answer that question? The Who Rider's question? Go ahead.
How far can the telescope see into space? I guess he's asking. What's the farthest thing we've ever seen? I don't recall. Many millions of light years.
88 million light years, 100 million light years away, actually, with some of the galaxies we've seen.
Ever discovered something new? I don't know about that. We saw a meteor hit the moon once during a lunar eclipse.
Right, and that was new. We're one of 5 groups on the planet to see that.
Yep. And Andrew Tedeschi's question, I have no idea how to answer that. I'll leave that one up to you.
Mark, have you watched or come across the research from the Seekers of Skinwalker Ranch about possible portals, wormholes? I've seen no actual evidence of it, because the thing is, the show goes on and on and on, but they never actually give you a conclusion. And I watched that show, and it's like what they're saying is, we'll see you next season. And you leave without any answers. And it's like, oh man, that's no good.
That's like Secrets of Oak Island or whatever it's called.
Yeah. Yeah. Yeah, Michael's Asylum, that's actually out there in our I'm gonna redo this because it's not it's actually out there in our stream list, and we were right at the height of the lunar eclipse. We saw a meteor strike the moon, and it was a beautiful flash of white light. It was incredible. So I think that would be very fun to watch.
That was
20th of January 2019.
2019, yeah.
Yeah. It was very cool. We thought it was a glitch. We thought it was just a video glitch at first. We didn't know it was a meteor until the next day when we started getting reports that we might have caught a meteor. Paul Martin asks, do you have a preferred approach, and what step size do you use? I picked up some great tips. Oh, you talking about the step size for the focuser, Paul? Let me know. Daisy and Zoe Amethyst say the meteor strike to the moon was our favorite event. Heck yeah. It was cool, wasn't it? It was really cool.
Somebody pointed out later in that same stream that it had happened, didn't it? And we went back and found it.
Yeah. Yep. Yeah, the autofocus step size. I'm using 12 discrete steps. Some people use 10. Some people use 20. It depends on the resolution they want of the curve. Either way, it's an interpolated value. I can see that this one is going to be fooled as well. The reason is because there's just not enough bright stars in here to do it. So what I'm going to do is move us to another field real quick and refocus. Let's go over into Comet. We'll go there. And once we're there, we should have enough stars to focus on. Yeah. Quite sure we can focus here. Okay. Okay. All right. Now we'll focus here.
Excuse me again, just a second.
Yeah. Ronald is here. Hello, Ronald. How are you? Michael Hedrick says, Mark, what websites do you use to identify the unidentified? Well, that's actually a good question. I usually go into Simbad, SIMBAD, sim as in simulator, and bad as in bad boy. Okay, we found our... So, I'll let it finish, and then it's now going to move the telescopes automatically. It's going to focus. It should already be, but... Okay. There we go. We had to wait for some Starlink satellites to come back. All right. All right, now let's go back to our comet. There we go. You can see the telescope moving up there. There's our comet right there. Fantasy. I can't believe it. This might be the only time in the history of the stream I got to go to bed. Well, that's okay, because during the summer we actually start earlier or later because it gets dark later. So it's fully understandable, my friend. Ooh, look at that satellite whipping through right there. See, you get to see all this. This is all being recorded, remember? That's cool. Now, knowing where we are in the sky, knowing where the comet is, knowing the time, you can go back and find out exactly what satellite that was. Yes, sir. Yes, sir. Okay, let's move over to our last series on this comet tonight. Hope you guys are having a good time tonight. It's kind of fun just hanging out and doing a comet study. 20,000 milliseconds. We're going to do this for 20 seconds. We're guiding, you can see by our numbers there. And let's get out of the low light mode and go into our live stacker, dynamic stacker. Clear the last image. Okay. And
it's moved a little farther past that star now.
Yeah. You're gonna find out in just a sec. Pumbaa. Here it is. Ta-da! It was over here earlier in the night, folks. And I know Izabela, she's gonna create a video to show it. It goes ding 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 ding. She may. She doesn't have to. Thanks, Izabela, for putting that up. Okay. Last night it was here. Just above this star. And now it's all the way over here. It's quite a distance. Maybe about 35,000 miles an hour. Maybe. Palmerin says, will you take your flats after refocus? I'm off to work soon. We'll be there live streaming tomorrow. I'm not sure if we'll live stream tomorrow. Okay. Thank you, Andrew, for that comment. That's very nice. Yeah.
Ronald's asking the comet's name again.
Oh, yeah. Thanks for reminding me. It's this. It's Comet 2023 A3 Tsuchinshan Atlas. Tsuchinshan Atlas. And this is a galaxy hiding out in this location too. That's right. It moves. No, that's Chinese, Ronald. Sushinshan. Just say Suchinshan. Or I think it's pronounced Suchinsan. But I could be wrong. Ronald, I was close. Yeah. Okay. All right, let's save this. 7. Right here. And save exactly as seen. Oh, yeah, I got it. Okay, I have it set. Good. Very good. Let's move out this black level just a little bit to the left of the curve. Eke out any little data left in here. Maybe there's some more here. That's about the length of the tail. I don't think it goes much larger than that. You know? It's very interesting that when you look at these, it's hard to believe, but this nucleus right here, that point is just a few kilometers in diameter. But what we're seeing here is several million miles in diameter. And that's because the nucleus is made of these volatile ices and things, and dust. And when the sun's rays, the sun's light hits it, it will start melting the surface layers of ice. And pockets of gas trapped inside, will suddenly burst forth and plunge lots of this dust into the area around the nucleus and make what's called the coma, this bright area here that you see there. Then that dust will literally just stay in the orbit behind the, and it's not actually trailing behind the comet. It just went into the area above the comet here and just stayed there because there's no reason for it to follow the comet. The comet has very, very low gravity. So it's just leaving a trail of dust behind it as it goes. This is not actually moving like whoosh, like many people think. It's just sitting there in space, and so forth. That's how that works.
Say what?
I was talking about the dust tail versus, okay, the comet outgasses the dust, and the dust comes off the tail. Now, the solar wind pushes the dust a little bit, but mostly what happens is it just stays in the orbit of the comet.
Oh,
and
okay.
so when the nucleus goes around the sun, it comes back, right? But it leaves the dust behind as it goes. That's how it works. And they're very volatile ices, as I said. Carbon dioxide ice, water ice, ammonia ices, formaldehyde, methanol, and other hydrocarbons as well. Tholins, which are compounds. Some of these compounds are actually building blocks of life. So comets have brought that stuff to our planet as well.
I saw somewhere it was referred to as an Oort cloud comet. It's not periodic as far as we know. They Or I saw a number somewhere else. They said like its period may be like 80,000 plus years.
Mm-hmm. I think we'll know more the longer we observe it. Okay, we're going to clear this now and do one more sequence. Okay. That's visibly moved quite a lot in the time we've been looking at it, guys.
Uh,
It started here, and now it's there. It's really cool. Okay.
Su Chen Shan, or however it's called. It means it's from Purple Mountain Observatory in China.
Mm-hmm. Okay.
Purple Mountain is a good name. And the spellings for it are all over the place. Some of them actually start with the letter Z.
Mm-hmm.
Michael Hedrick has a question of you.
I'm looking at it. It says, Mark, the Pioneer anomaly? Is it pushing off course or time warping? Michael, I have no idea what you're talking about.
Pioneer spacecraft, I believe.
Yeah, that's what I was thinking. But,
I heard just a little bit about this. It's moving, or it's ostensibly not following the course it was given. Something of the sort.
oh, well, I imagine that once you get out to a certain point and you get beyond the realm of the sun with its overwhelming gravity, then you're free to interact with other bodies out there, other stars, and you could have a minute effect once the sun's gravity is lessened to the point where other stars can also make their gravity noticeable. So maybe we're talking about that. I don't know the answer to whether the Pioneer spacecraft could feel the expansion of the universe.
Oh, it's too close. You're measuring cosmic scales when you're talking expansion of the universe,
Yeah.
like intergalactic distances at a minimum.
Okay. All right, this is our last one in the series. All right, guys, we will pick this up probably the next couple days, and the comet's gonna be way over here when we're done. So we're going to quit for tonight, and I just wanted to thank you guys for coming out here and hanging with us. Told you it wasn't going to be very long. Okay, beep, we don't need that up there. And we will see you again very soon. You know, so take your last look at it in regular 1 second exposures here. And we'll check back in with it in the next couple days here. So hope you guys are doing all right. Thank you for coming. Thank you for being here. And once again, if you if you would really see your way, join our Patreon. We don't, there's a value for everybody. Just join our Patreon and enjoy the benefits of what we offer with the Patreon. You just read about it on our site. And we look forward to seeing you guys again in the next stream. So I hope you have a good night, and good night, everybody. Ta-ta. Say
Good night,
John
Bonnie. Good night, everybody.
All right, everybody. Have a good night. We'll see you later. And Bonnie, where you been? On a Hot 77, that's Bonnie. Thanks, guys. We'll see you later.